Or you can always go back and look at the slides online too. Here we go. What are we going to do? It's asking for mass, percent. So what do I need to put on top? 15 grams. Why? Because that is 15 grams of my solute. What's the name for this solute? Anybody know? What's the name of this solute right here? Sodium carbonate. Sodium carbonate. Very good. All right, so that's the mass of the solute. What goes on the bottom? The mass of the solution. What's the mass of the solution? 235 plus 15. Whoops. Oh, y'all know, I didn't tell y'all. This is my shorthand way for writing solution. This is, when you see me write SOL''N, that means solution, okay? That's too much for me to write. So what's the answer? 6. Okay? We all see how we did that? That you have to add the two together because it's the mass of the entire solution, not just the solvent. Okay? We're good? Would y'all tell me if you weren't?
We didn't.
No.
Yeah.
This one's too easy. This one's easy. We're going to use this conversion later. All right. Volume is the same as mass, except now instead of using grams, you're using what? What are units for volume? Milliliters or liters. In this case, we're going to use milliliters of solute divided by milliliters of solution. Okay?
So it's literally the exact same.
It's the same thing except it's milliliters instead of grams. Milliliters of solute divided by milliliters of solution. So those couple of us in here that are 21 years of age or older, when we go to the grocery store and buy an alcoholic carbonated beverage known as beer, and it's 4.5%, it is 4 milliliters of ethanol for every 100 milliliters of solution. Okay? Does that make sense? It's the same thing. You have to have the total volume, not just the volume of the solvent on the bottom. Okay? It's the exact same problem, just with milliliters instead of grams. We're good? Then you can mix the two units together. You can have mass volume percent. Mass volume is mass of solute in grams divided by milliliters of solution times 100. That'll give you percent. Note, when you write these percentages, you always have to put that ratio there. Either M over M for mass, or V over V, or M over V. That way people know what you're talking about. I personally hate these percent concentration units. However, lots of people in the medical field still use them. Okay? Percent concentrations don't tell me anything about reactants and stuff. It's a different unit we're going to use. It makes more sense to chemists. Okay? Same thing as mass, except now you have mass over volume. Grams over milliliters. So, because these are all have two units, top and bottom, you can write conversion factors with all of them. Can you write conversion factors for each of these? Can we do the first one and then y'all do the next two?
Yeah.
Okay. Let's look at this. This is 8.5% mass sodium hydroxide. What is that telling me? It's telling me I have 8.50 grams of what? This is my solute. What do you think goes on bottom? It's a percentage. What always goes on bottom in percentages? 100, right? 100 what? 100 grams of solution. What's the other one I could write from that?
100 grams of solution over 8.1.
Exactly. Exactly. Just flip it upside down. So you guys should be able to write these other two. You guys should be able to write B and C. Do it real quick, and then we'll put it on the board. Okay? Ready? So, what do we have? 5.75 what? Milliliters of ethanol over what? 100 milliliters of solution. Or flip it upside down. Now the other one. 4.8 grams of hydrogen chloride over 100 milliliters of solution. Or flip it upside down. Okay? Make sense? All right. Now, the unit that chemists use the most is this unit right here. Molarity. Capital M equals moles over liters. Moles of solute over liters of solution. Okay? Now what happens if you're given grams and liters? What do you have to do? Convert. How are you going to convert from grams to moles? Come on, Brianna. How are you going to convert from grams to moles, Brianna? Huh? What's that thing you got sitting there in front of you? What's the word that we use for that? We're going to calculate the, remember? Molar mass?
Yeah,
Molar mass. You knew that, didn't you?
Yeah, I knew that.
Word wouldn't come to her. I could tell she's sitting there going, I know, but God, if I know the word, I'd tell you, because it's in there somewhere. You keep stuffing more stuff in there, how am I supposed to find the right thing? Okay? So if you're given grams and you want moles, you gotta use molar mass. Okay? Moles of solute divided by liters of solution. All right.
Sorry.
I wish I could ignore this down here. Don't read that. It says, what is the molarity of 5.5 liters of sodium hydroxide solution if it contains 6 grams of sodium hydroxide? Here's how I'm going to attack this. I have 6.00 grams of sodium hydroxide. And I have 0.500 liters. But I don't want grams over liters. What do I want? Molarity. I want moles over liters. And I have grams over liters. So what do I have to do? Huh? I got to use a molar mass to go from grams to moles, don't I? So I'm going to do 40.0 grams of sodium hydroxide is 1 mole of sodium hydroxide. How did I get that? From the periodic table, right? Sodium's 23, oxygen 16, hydrogen's 1. Add them together, gives me 40 grams. It's 1 mole. Now look at my units. What happened? Grams of sodium hydroxide canceled, and I'm left with moles over liters. This will tell me the molarity. 0.50 molar. Okay? Oh, that's not right. I don't think that's right. Because they haven't divided by the volume yet. What's the answer? 6 divided by 0.5 is 3. 3 over 40. I don't know what that is. What is that? What's 3 over 40? No, 6 divided by 0.5 is 12. 12 over 40. What's 12 over 40? Or 6 divided by 20. It's what? 0.3. Everybody sees how we got that? 6 divided by the denominator, which is 0.5 times 40, 20. So 6 divided by 20, 0.3, I guess. I can't do thirds in my head. Bless you. All right, well, you guys should be able to do this one then.